Integration by parts, a technique within calculus, is used to compute the integral of the product of two functions. Integration by parts is based on the product rule of derivative. The product rule of derivatives is as follows, a well-known concept among students, right? When we integrate both sides of this equation with respect to x, it leads to the following expression. Rewriting this expression immediately yields the formula for integration by parts. Integral u dv equals uv minus integral v du. Usually, the choice of u aims to simplify the function upon differentiation, while dv is chosen to be easily integrable. This method allows for a more straightforward computation of the integral of the given function. Let's delve further into this concept with the following example. Integral cosine inverse of x dx. Let's choose the function u to be the cosine inverse of x. Then, dv equals dx with the coefficient being 1. The function u should be the one to differentiate, while the function v should be the one to integrate. Let's differentiate u. The derivative of the cosine inverse of x is -1 over square root of 1 minus x squared. So, du equals -1 over square root of 1 minus x squared, dx. And dv equals dx gives us v equals integral dx. And it becomes x. Now let's apply the integration by parts formula. Integral cosine inverse of x dx equals cosine inverse of x times x minus integral x times -1 over square root of 1 minus x squared dx. This becomes cosine inverse of x times x plus integral x over square root of 1 minus x squared dx. Taking the latter integral separately, we'll use a substitution method. Let's substitute 1 minus x squared as v. This gives us dv dx equals -2x, which transforms to dv equals -2x dx. Hence, x dx equals -1/2 dv. This expression will replace the x dx part in the previous equation. The integral becomes cosine inverse of x times x minus 1/2 integral 1 over square root of v dv, where integral 1 over square root of v dv equals integral v to the power of -1/2 dv equals 2 square root of v. By substituting, the integral becomes cosine inverse of x times x minus 1/2 times 2 square root of v. Do not forget the constant of integration c. By substituting the original expression, 1 minus x squared, into v, we finalize the equation. Integral cosine inverse of x dx equals cosine inverse of x times x minus square root of 1 minus x squared plus c. Although the process may seem complex, by practicing the combined use of integration by parts and substitution, it becomes more manageable. Good luck with your studies. See you next time.